Good afternoon. So I think thanks all for attending the session. And today it's my great pleasure to actually introduce you Ikuo, who is basically here from Line Corporation, all the way from Japan for this particular session. Thank you, Ikuo. And my name is Sandeep Balani. I'm going to be starting the session, and this is Precy, who is going to be going through some of the technical aspects of it. And effectively, what I have done is the session is in 3 parts, right? So I'm going to provide introduction and the introduction part, and Ikuo is going to go detail into how Line uses some of the infrastructure pieces and what were the enhancements that they were looking at in Sonic from their data center deployment perspective. And then Precy is going to talk about the enhancement that we have done specifically for those cases, right? So in 2014, 2019 actually, Gartner said that Sonic is trending to be Linux of networking. And today we know that Sonic is part of Linux Foundation, right? So this is, I would say, just the first step, right? But we know it's happening, right? And with the Sonic being open operating system, open NOS, we see a lot of ecosystem partners, whether it's ODM, OEMs, hardware vendors, cloud providers, silicon providers. It's has a great community support as well. In fact, I was looking at recent Deloro report, which basically forecast that about 25% of business in data center switching by 2026 is going to be on disaggregated software, disaggregated hardware plus software, right? And the next point is basically talks about that initially the Sonic momentum was starting in the hyperclouds, but we see more and more momentum to be happening in not just hyperclouds, but is going to tier 1, tier 2 clouds. It's also happening in service provider, telcos, and in fact, we are seeing more happening on the enterprise as well. And believe me, this is just the starting point, right? We are seeing a lot of emerging use cases of Sonic, where Sonic is now going in campus, as we know, right? We have new initiative called Disaggregated APIs for Sonic Host, where Sonic is going to be potentially running on each NIC, right, or DPU, right? You have basically distributed disaggregated chassis, which is another stream where we are going to make sure that modular chassis in the routing framework and AI/ML framework are very important for customer to basically deploy. And last but not least, we saw this morning how P4 integrated network stack pins is basically an integral part of Google's network going forward, right? So all these projects tells you that what does it mean? What it effectively means is you are going to see more and more number of Sonic devices in your network, whether it be switch, network routers, distributed chassis, and DPUs, right? So, and what that means effectively is that when you have more devices, these devices are going to scale significantly, and in those particular cases, you have a big management framework on top, you will have orchestration framework, you will have controller framework, you will have monitoring framework, right? So how we are going to deal with the scale of devices that they are going to be very different, varied, right? Switch, router, DPUs, and all that. How we are going to make sure that it scales, Sonic continues to grow. And the answer for that, in my opinion, is the unified management framework that basically makes sure that we create a very nice uniform management framework where Sonic continues to enhance and grow in its from where it is, right? So we have REST server integrated in there. We have GNMI server that basically we see Google and some other companies are using it, right? So that's basically the key aspect for make sure that Sonic continues to be growing, right? Now, as far as the integration of the management is concerned, we have 2 different models, right? On top of this unified management framework. The first model, we call it as agentless management option. This option is where a customer who is basically providing management solution will use the native REST API or will use the native GNMI API through the gRPC interface and will communicate with the device, right, the Sonic device, and then it will basically use those interfaces natively to provide the user interface. In fact, PIN's project, the SDN controller is an option for that. And if last year we did a session on Sonic automation with AT&T Open Daylight controller, that was using the REST API interface. So this was the model number 1 that we see. The model number 2 is even more interesting because in this particular case, What end customer may end up doing is, end customer may end up doing running a container inside the Sonic. And this container is going to be talking to Sonic device directly, and it will basically either use REST API, GNMI, whatever interface is available in Sonic natively, and it will provide all the northbound interface to their user controller. And this container can provide the infrastructure capabilities to do much smarter orchestration in the top. Last year, when we talked about AOS integration with Juniper, which is part of Apstra AOS integration, that was talked about last year. In that particular case, what you noticed is that Apstra agent was running as a controller on the Sonic interface, and they were using basically REST APIs. Similarly, in future, you could have a custom agent that will running in here as a container and could use any of the API. In this case, the main thing that we are focusing on is to make sure if you are running in a controller-based model or the agent-based model, we need to make sure that Sonic supports that model and provides a very good TPCM infrastructure, third-party container management infrastructure, so that container can be managed to make sure that it can monitor we can monitor its memory, CPU, to make sure it has right network resources. And this was important because if we let it go amok, in that particular case, it could affect system. So with these things, now I'm going to hand it over to Ikuo to talk about how Line utilize some of these capabilities in their network. Thank
you. Hi, everyone. Let me start with a little bit about Line. We are a communication messaging platform focusing on Japan, Taiwan, Thailand, and Indonesia. And the number of users in these countries is over 170 million. And they use our app on a daily basis. And for about infrastructure, here's some numbers to explain the scale. Over 99,000 virtual machines are provided by our private cloud that embrace our core services such as messaging and fintech. And to cover the network demand, we decided to adapt the closed network 3 years ago. And in this slide, I'm going to talk about the network architecture and the orchestrator. So about a closed network, our closed network is a so-called 5-stage closed with multi-vendor switches. I depicted the topology in the dotted box, and from the bottom, top of racks, spine, and super spines. And the number of switches in a typical closed network is from 200 to 400. To provision and manage these networks, we developed our homegrown orchestration tool. And recently, we deployed Broadcom Sonic nodes in our network and started to manage them under our orchestration tool. And now I want to walk you through the architecture. And first, it has distributed agents on a switch running as a container. The switch watches the data in the data store and updates the configuration according to the change in the data store. And so the architecture design can be categorized as agent-based management. And second, the other components, API servers to update the data in the data store, and ZTP servers to install our agent on a switch, and data store for multi-vendors. These servers, API servers and ZTP servers, are managed under Kubernetes. And we use etcd for data store for switch configuration with its revisions. In our daily operations, network operators and external components in our private cloud call the API servers to update the data. And the agent detects the change and run Ansible scripts to update the configuration according to the network OSs. We use tags in Ansible to switch the playbooks for the network OSs. And in this design, we achieved 2 goals. One is minimum development cost to support new vendor switch, and integration with external components. First, minimum development cost. To support new network switch or network OSs, the agent is the main point to change that handled northbound interfaces of switches. And the other parts, like watching data store and API servers, do not require much change. For example, to support Broadcom Sonic, we utilize the REST API, but the other part, like our API servers and data stores, does not much require big changes. And the second part is integration with external services, external components. And the API server is our main interface for our orchestration tool. So that's why it's kind of easy to integrate. And plus, the execution of Ansible playbooks is triggered by the change in the data store. It's not by human operation. So the workflow of integration is smoothly going without any manual operation. So in this slide, I'm going to talk about monitoring. There are two parts. About logs, we use FluentD in servers and switches to forward the message to Elastic Stack. And for metrics, we use the console server discovery in Prometheus server to detect the scraping targets. So in a way, we don't have to add scraping targets at the network deployment. We usually add 200 and 400 nodes, so that detected by service discovery. And for exporters, we use multiple exporters for network OSs, FR routing, and our agent. For our agent, we gather metrics like to detect the anomalies for the failure of Ansible executions. To summarize the previous two slides, I'd like to highlight that we use multiple open source softwares running as a container on a switch. And this topic will be, and as we manage multiple third-party containers, we faced some issues, but it will be covered by the next speaker. So in this slide, I'd like to share how Sonic helps us leverage open source softwares. And first, it's design. Sonic has container-based design, therefore, it lowers the hurdle to try open source software on a switch with the resource limitations. And second, open source components in Sonic. And particularly, FR routing is widely used in our use case. For example, we run them on servers for routing on the host and software load balancers. Therefore, we invested our time and resources for FR routing. In fact, we upstreamed some patches for FR routing to support the feature SLv6. A little bit about the use case of SLv6. As we provide fintech services that require network isolations. To achieve that, we used SLv6. For data plane, Linux VLFs encapsulate packets from virtual machines with SLv6 header to provide us isolation from underlay. And for control plane, FR routing distribute the SLv6 L3 VPN route information with BGP. The patches listed here enable that use case. So now we have Sonic in our network. That means we stepped forward to leverage these enhancements in our closed network as well. So now, next speaker will talk about the third-party management, container management. Thank you.
So as what we know so far is Sonic is provide the user ability to run their own containers in the Sonic system, right? And we all know like those third-party container that can be the customer build or it's the open source based in the communities. But since we know they are the external extension to the Sonic, therefore they require additional capability to manage those third-party containers. So with this in mind, therefore we have this TPC enhancement is implemented. So the first thing we can do is we provide a seamless install and upgrade and also the deletion for the TPCs, right? And so the users actually can install and upgrade from various resources, from the community or from your local disk. And you can use different protocol to download it. And also the same thing is really important is which is limits TPC resources like CPU and memory and disk. Like I said, we don't want the third-party container to solve our core SONiC services, right? And so another one is we allow the user to customize the TPC with the various arguments, because some of the container you will run at, for example, in your startup arguments or your certain command arguments. So we allow the user to customize at TPC installation time. And another one is important is we support the TPC for the management of VRF. So therefore, like, so you can communicate with the external world. And another one is we allow user to a TPC dependency on the SONiC services, which means is you can specify if you want to, TPC was running after the system's ready, or you want to run with a certain sequence. And the last is really, it's definitely, we need to taking care of the, for example, the TPC upgrades, which is data migrations without disturb the SONiC services. And also, we also need to make sure we migrate our TPC during the SONiC upgrade. So this is our TPCM, the upgrade framework, which will address two user cases. The first one is during the, you're running on the TPC on the existing SONiC image and you want to upgrade the TPC. And so that will provide a pre and post a hook support, which is taking care of the data migrations. And another use case is with during your SONiC migration is, so remember, so therefore we're taking care of the TPC migration, also taking care of at auto restart. So right now, if you do the warm boot and system reboot and so on, your TPC will start automatically as well. And the last is the call to actions. So TPC Enhancement HDLD, which is built on top of the SONiC application extension framework, it's already published in the community, and we are welcome you to review the high-level design and then give us your valuable feedback. And then when we also request, you know, when we publish a code, we also request you review the code and give us the feedback. And that's end for the, thank you for our presentations.
Thank you.
Thank you. Any question?
Hi. So basically, I am wondering here, what's the end game here in terms of integrating third-party containers? Are you planning to eventually do more or less what the mobile applications are doing? Like you have a catalog of applications, you define isolation properties, what certain applications can and cannot do, and you have one centralized place that you can click or select in the config. Please get me that application.
So what I would say is that it really depends on the use case for us, right? And what we want to make sure is that for anyone to deploy SONiC in a production network, we need to make sure that network is able to provide a safe, sound, and reliable and secure environment for those applications, right? So in that particular case, for us to make sure is that customer, like Line had 4 suites of applications, 4 suites of container. We want to make sure that those are critical for them. For some customers, maybe it needs more applications. The end game really is that because as SONiC provides a container microservices-based architecture, we want to build on top of it and make sure, depending on the hardware and software resources available in the system, you can expand and reduce based on specific platforms.
Okay, sounds good. So actually here, it's more of you're trying to describe the technical measures of what we potentially need to add to support that. But like, I was also wondering about the organizational or from the product management measures. Like, are you envisioning some form of a centralized catalog of the applications that we can all share across the company?
Oh, I see. Okay, I see what you're saying. So the catalog of applications. So at this point of time, some of the applications, as Ikuo talked about, are already in the community, the containers, right? We don't have a catalog yet, but I think in future, as we build upon more applications, that could certainly be part of the community as well.
Absolutely. Thank you very much.
Yeah, thank you.
Any more questions? All right, thank you.
Thank you, everyone.